a lot of investment is happening in our college and universities. Princeton, for instance, Princeton will be, 300 years old by 2050. I think the year 1745, right? So Princeton was founded before the United States. So, as I'm sure you're aware, a lot of universities have taken an environmental pledge, a carbon mitigation pledge, right? So they're making investment to decarbonize, their campuses. One of the larger sources of emissions on campus is the central plant. So, but again, if you make an investment at scale in the central plant, that really reduces the risk of trying to do it in a few hundred, in 100 buildings or more.
Welcome to Geothermal Unleashed, where we're going to explore the cutting edge of geothermal energy. I'm Elizabeth Cambry from the Valorec New Energies team, and I'm here to educate and document geothermal's rise in the global energy transition. And I want to give a special thanks to Think Geoenergy. I'm very excited to welcome our guest today. It's Rob Thornton, the CEO of the International District Energy Association. We have a lot to talk about today, and I want to jump right into our discussion. But before I do, Rob, I'm going to ask that you introduce yourself, and we'll go from there.
Well, thanks, Elizabeth. It's great to be with you, and thanks for the opportunity. So my name is Rob Thornton, as you said. I'm the president and CEO of the International District Energy Association. We're headquartered outside of Boston. We have about 3,000 members worldwide, 28 countries. The majority are in North America. Our members own, operate, maintain, innovate district energy systems. So those are central plants with underground thermal piping networks that provide steam, hot water, chilled water to cities, campuses, communities. Very often, they're beginning to utilize Geo-exchange. In fact, I think Boise State, one of our members, began operating in 1892, right? So IDEA has been around since 1909. Next year will be our 116th year. And the industry is actually, growing quickly globally. And it's great to be here to, talk about geothermal as part of the quiver of arrows.
Wonderful.
Or arrows in our quiver, yeah.
116 years, that is fascinating that IDEA has been around that long. So I want to ask my first question.
Yes.
Can you talk a little bit about the evolution from coal-fired plants and how we've moved and evolved to today's decarbonized solutions? What has that journey looked like?
Yeah, so district energy really was one of the first environmental strategies for cities. Back in the 1880s, the Industrial Revolution, power plants were really first innovated in downtowns. Thomas Edison, built the Edison illuminating stations. He was trying to sell electricity to his neighbors. And he was actually asking them to convert to alternating current, AC. So the buildings around the generating stations would say, well, if you want me to buy your electricity, that means I need to shut off my dynamo, my little generator in the basement, which was often a little coal-fired boiler with a generator, because I'm going to need heat too. So the customer said, if you want me to buy your power, I'll need for you to also supply heat. And then it was in the form of steam. Edison actually realized very early on he couldn't make a profit just selling the power. He had to sell the steam heat too. And so district energy was really the nexus of it, although it dates back to the Romans, if we were real about this. So in North America, the electricity generating stations were often located in the center of cities, combined heat and power, cogeneration, making heat and power in their communities. Manhattan today has still one of the largest district energy systems on the planet. It's 100 miles of underground steam main. But back in the day of Thomas Edison, there were 26 separate steam utilities in downtown Manhattan. Over time, they became acquired, integrated, consolidated. But that was sort of the genesis of district energy. We grew up as part of the electricity industry.
That's super interesting. So you mentioned you're enabling cities to help them decarbonize, but it's also true that you're working with universities and campuses. So can you talk a little bit about that and how we're transforming universities?
Yeah, let me back up because I failed to really answer your first question.
Okay. Okay.
So, no, I'll back up and I'll come to the campuses. But so what's happened over time in cities is, so originally these were coal-fired power plants, and then they evolved to like gasified coal. That was the next phase, and then in the 1940s, 50s, they were oil-fired, making heat and power. Then in the 60s and 70s, they converted to natural gas. Today, we're integrating electric boilers, large heat pumps, renewable electricity, electrifying the steam. And so the advantage of district energy is the same today as it was then. Make an investment in the central plant and deliver those benefits to hundreds of buildings at a time. Having the aggregated load is, and the investment, portfolio, the scale, the economies of scale, that has been, so district energy has evolved continuously. We continue to do that, bringing us to today. So what we're really seeing, that a lot of investment is happening in our college and universities. Princeton, for instance, Princeton will be 300 years old by 2050. I think the year 1745, right? So Princeton uh, uh, was founded before the United States. And as you're largely, I'm sure you're aware, a lot of universities have taken an environmental pledge, a carbon mitigation pledge, right? So they're making investment to decarbonize, their campuses. One of the, larger sources of emissions on campus is the central plant. So, but again, if you make an investment at scale in the central plant, that really reduces the risk of trying to do it in a few hundred, in 100 buildings or more. So, the economics work. It enables the acceleration of decarbonization because you're doing it in one place, providing the benefit downstream to all the connected buildings. It's not simple. It's not easy. Converting the central plant is actually the easy part. Sometimes changing the thermal network, if it's upgrading from like steam to a hot water network, which Princeton, Oberlin, Carleton College, some of the universities are doing or have done. That can be an endeavor. But really, it's turning out that the more challenging aspect of this is converting the buildings to lower carbon, lower energy, energy utility index. So, because if you look at a campus like Princeton, much like a city, there's a whole spectrum of buildings from, very innovative, recent, low energy intensity to landmark, historic, institutional buildings, and they all have sort of different veins and arteries and operating systems, HVAC systems. So the and I think this is something we'll talk about, but at IDEA, one of the things that we enable as an association of members owning, operating these systems is the collaboration, the collegial sharing of information. Oh, how do you do this? What worked? Where did we have a challenge? And that's what we pride ourselves on, I think, is helping our members, kind of solve problems, but not learn from each other, so that, a mistake made at Princeton isn't replicated, somewhere else, or it's done
Sure.
more efficiently, more cost effectively.
Okay, so that's great. Can you give some examples of the innovation that you've seen from your member institutions and how that's reshaped?
Sure. So here's one. It's a little bit unique at Cornell University. in the year 2000, uh, that was a time when CFCs were being phased out or soon thereafter, right? So people were really trying to repower their chiller plants and understand how best to do that, replacement for refrigerants. Cornell had already been studying using the deep lake, Cayuga Lake nearby, as their source for cooling. It took quite a bit of time to design it, get the environmental permits, but they began in 1990 taking cold water out of the bottom of the lake, bringing it to a heat exchanger building, and then pumping it uphill to provide air conditioning to just under 20 million square feet of buildings. So what Cornell did is they traded an electricity bill, buying electricity from the local provider, to a bond payment, and uh, and that bond was amortized over 15 years. The cost for cooling was dramatically reduced by actually a factor that went from 100% to like 10% of operating costs. And Cornell, shared their technology, their solution, the whole, process. That didn't directly result in, but Toronto then moved forward using the cold water out of Lake Ontario. Today, that system provides air district cooling to over 120 buildings in downtown Toronto. Now, it wasn't a direct, kind of plug and play, but a lot of the technical solutions, innovative, and even the policy conditions, have been shared, improved, amplified. So that's one example. I think our member institutions, in fact, we're holding our campus energy conference in Boston in February. Shameless plug, but there really is huge exchange, and a big track of that is geothermal on campus. Geo-exchange, building how to build bore fields, how to handle construction sequence, the vibration, the noise, the cuttings, the process, and then that integration. Not only the technology, but the financing, leveraging IRA, the different strategies to implement something of this scale.
Yeah.
I'm probably not giving as granular an answer as I should have, but
No, I think
there's a lot of technologies at play.
no, it's great. And so you mentioned Cornell, and do you consider Cornell to be kind of a little cutting edge when it comes to some of their projects, leaders in this space? Because they're doing something quite interesting, and maybe you can talk a little bit about their deep geothermal project.
Yes, Cornell has really been a leader in our space for 30, 40 years. Very involved in our association, collaborating, sharing, exchange. Yeah, so Cornell has drilled a 10,000 foot deep borehole, on campus. So that's nearly 2 miles deep. They're currently testing all the stratification. They have, the data recovery. They're analyzing that. I think it was supported in part by a grant from the Department of Energy. Cornell. So this is deep geothermal, like hot rocks, which we often see in the U.S. in Idaho, California, the geysers. That's sort of the legacy where sort of direct use geothermal has really been prevalent. But I think as we look to Mother Earth for a lower carbon solution, there really is a great deal of study underway for direct use, deep geothermal, and thermal, not just making electricity, but actually leveraging the thermal. So back to Cornell. Yeah, I think their plan would be not dissimilar from what's happening today in Aarhus, Denmark, the second largest city in Denmark. NRG is investing in a whole geothermal, kind of replacement of their district energy, thermal supply. Cornell is looking to do the same. Now that the well is drilled, they'll be able to replace, their thermal energy is is natural gas predominantly, cogeneration, surplus heat recovered, very efficient, very reliable, very resilient. But Cornell, like many institutions, wants to decarbonize and reduce the tier one emissions on their campus. This will allow them to essentially replace, um, you, you know, natural gas produced thermal with geothermal, earth produced thermal. But they already have the district energy network in place, right? Not
Right.
unlike ours, right? There is already a thermal grid serving, 20 million square feet, 150 or 60, buildings on the campus. So it's a little chicken and egg. They already
Right.
have, they already have both. They have the chicken.
Right.
I'm not sure what they have.
And so it's my understanding that they're going to go in and hydraulically fracture these wells. So do you think we're going to start seeing that at more universities?
It's possible. You know, uh, it, Unlike the EU, which really has, obvious carbon incentives, emissions incentives, kind of, that driver. I think, I think those sort of externalities, those economic drivers, do reside on campuses. I think our institutions are being compelled not only by the trustees and the leadership, but certainly the students. They want to enroll and be at a mission centered institution. So I think the universities are really kind of responding to opportunity and pressure from sort of both sides. Um, the As far as the fracking goes, I think we are going to see um, the skill sets utilized in extracting natural gas and sort of directional drilling. If they can be deployed to just recover thermal and utilize thermal, and maybe it isn't thermal to a temperature or pressure that will make electricity, but if it can displace what would otherwise be, carbon centered heating, I think that's a trend we'll see more of. Um, it's certainly in the EU, the Energy Efficiency Directive, a lot of the externalities are in place. We don't have those same kind of policy drivers here in the U.S., but we are seeing cities and states that are asking their utilities and trying to help their municipalities to decarbonize heat as well.
Okay. So let's stay on this topic of campuses.
Yep.
Um, so we've got Cornell, Princeton, Ball State, correct, is also looking at geothermal. So as they shift from steam to a hot water district or implementing some other sort of geo-exchange system, what are some of the challenges and then successes that you've observed?
Yeah. I think I want to tip my hat to Princeton again. Ted Borer, who's actually retiring from Princeton, but still will be active in the industry, serving on our board. Tom Nyquist, his colleague for many years. Princeton has and their contractors, Whiting, the people that have actually drilled, I think, nearly 1,000, 800-foot boreholes on campus. One of the challenges is, communicating to the community that this work is underway, why it's happening, the benefits, kind of coordinating what would otherwise be disruption. You're implementing the quad, you're diverting students from pathways. The researchers nearby are dealing, they're contending with, and in the implementation stage, there is the rigs and the vibration and the noise, et cetera. Managing that, mitigating that. I think we Princeton has shared a lot of that expertise, and they will do that again at our campus energy conference. So, I think it's useful to learn from. Okay, building a plane as we fly. Here's how to get kind of do that. I think the big challenge is the institutions, they have the advantage of a long investment horizon, right? I mentioned Princeton, 300 years, Cornell, 250. So they're going to be in that place, that location, really for another century at least. And that gives them confidence to make, kind of long life investment, decisions like this transition. That isn't always the case in the U.S. for, industrial settings or commercial entities or, corporations. They don't have that assurance of utilization, to amortize investments like this. I think the lessons are that uh, it's how to manage the capital risk, how to stage the transition, how to implement both, the physical, construction, and again, as I mentioned earlier, I think really what some of the primary findings are that the generation and the distribution, are solvable. It's the end user and the range of technologies in these buildings and managing what might be disruption or and the seasonality, right? So you can't just empty a building. I mean, you can, and people do, but on a campus, if a building is kind of scheduled for restoration or an adaptive reuse, then that's an opportunity to do the HVAC, the conversion. But if it's not, or you have to, over the summer, change the heating system, take out the radiators, put in the equipment. UVA is under University of Virginia, Charlottesville, undertaking a similar investment in a new campus contiguous to theirs. So there's really a lot of experience. I don't know that there's one single thing. It's kind of locationally driven, but I think most people would say the more uncertain aspect is the end user, kind of the customer buildings.
Okay. So let's talk about the scalability. This is my last question on the topic or theme of campuses. Does the size of the college matter? So you've got mid-sized colleges like Carleton and Oberlin. So how does that impact? How does implementation of geothermal impact on different size colleges?
Yeah, I mean, I think so. Ball State in Indiana is more of a land grant, sort of, a lot more space. Princeton is a little more of
Okay.
it's not an urban campus, right? Oberlin is very integral to the whole community. So I think one thing I just share is that it's not like 100% at a time. Like it's not like flip the switch, the whole campus, all 15 million square feet are converted. It's segmented. Sometimes it's done by, kind of a district or a segment, or it's done. So if you're replacing the distribution network, then I think at Princeton, and what they've built is they call it Tiger, and that's also their mascot, Princeton Tigers, but thermally integrated geothermal energy resource, right? They've taken a kind of a segment of the campus and converted, I think a dozen or 15 buildings at a time, and then they'll do the next. So it's kind of like Lego. You kind of build it in segments and sequence. So a campus the size of Oberlin, I think the student population there is in the range of 5,000 students. Princeton, I should know these numbers, but I think they're not University of Texas, right, with 70,000 people on campus. UT Austin.
How many are at Cornell? Just to give comparison.
I think Cornell is in the range. I think Cornell is in the range of 10 to 15,000. I should know that, but I went to Tufts University when I was there. I think there was like 3,200. It's grown a little bit. Yeah. So, not small, but mid, kind of the mid-size.
Right.
I think it has more to do with not so much the size of the campus as much as, where they are at this moment. Like Oberlin, I think, was facing, kind of a replacement investment. Dartmouth is undertaking a full-on conversion of their campus, shifting from uh, oil-fired, a district steam to a geothermal-based, hot water network. Um, I don't know the student population at Dartmouth, but I would posit that, like some universities, it's the economic engine for that, for that community. And I think the daily population is probably in the range of 5 or 6 thousand people. So
Okay.
it's not just student population; it's faculty, research, etc. So it's a small city, in large measure.
Okay. So it's modular. That's essentially it's a
Yeah,
modular transformation, but it helps if you've got some sort of infrastructure in place.
yeah. Well, it helps if you have the wherewithal, the insight, the game plan, the yeah. I mean, so in the case of both Princeton and Oberlin, they're replacing sequentially their steam network with a new hot water,
Yeah.
right? So it's not a one. They're not using the existing piping. They may be using similar rights of way or how tunnels. A lot of this is
Yeah.
direct buried, but yeah. So what's happening in cities today, and not to switch gears on you, but
Go
what's
ahead.
happening in cities is that the veins and arteries, the district steam networks are remaining in place, and they're uh, modernizing again the generation component to make steam, right? So uh, in these large cities like Boston, Philadelphia, New York City, San Francisco, you can imagine how complicated and expensive it would be to replace, in New York City,
Yeah.
Manhattan, 105 miles of steam main, right, serving 1,500 buildings. Incomprehensible investment. So again, looking back 140 years, now the next phase is to electrify the production of steam, and again, doing that with components. Electric boilers may be the first step, and again, it's not to replace 100% of the steam production. If you have an electric boiler, that might provide the base load, or maybe a lot of our district steam systems in cities were, as I mentioned, the Edison generating station. So they're
Okay.
connected to the electric grid at the wholesale level, right? And they have large substation. So they're basically positioned to leverage renewable offshore wind, and essentially, mitigate that risk for their customers. So what we're seeing in cities, San Francisco has installed an electric boiler recently. The electricity that'll make that steam is direct from a hydro plant nearby. So it's all renewable electricity that is making carbon-free steam. That solves a big problem for the buildings in San Francisco. They don't have to undergo a replacement, a disruption, a capital cost, put new equipment, put cooling towers on there. That it creates huge value and accelerates the decarbonization of cities. Uh, 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 Boston recently, our one of our members' vicinity just did a ribbon cutting on a new electric boiler in Cambridge at their primary station. It's a 42 megawatt electric boiler that will cover 30 million square feet. The district heating system in place in Boston and Cambridge is fully integrated. Serves, I think, around 200. I should know this number, 200 plus buildings or so. Um, so the electric boiler will be, customers can subscribe to have 100% of their steam, allocated to that investment, right? So Emerson College, occupies a small urban campus in Boston. They're they will be utilizing carbon-free steam for their entire campus. Now, it's like the electricity grid in a way, right? All the electrons that come into the grid are not all from solar or wind, et cetera, right? You don't paint your pipe directly, but the advantage again to buildings is that they can demonstrate that they're utilizing carbon-free steam with little. I want to say no. Well, in this case, it's no disruption to to the building, which I mentioned earlier is the primary challenge of converting. Our members in New York, San Francisco, Boston, Philadelphia, Denver, these large cities, the building owners are really it's confusing, it's complicated.
Sure.
They've only just recovered from COVID. Not everyone has returned to the space yet. They haven't really, so they're not eager to undertake a replacement of the heart and lungs of the building and disrupt tenants and have capital costs. District energy really de-risks all that. They can reclaim space. And so from our view, we can accelerate the decarbonization of cities by, again, modernizing the generating asset that's supplying the
Sure.
thermal energy.
So this is fascinating. Is when we start looking at this transformation of cities, I want to talk a little bit about the workforce and the skill sets that are required to do this. Are the workforce in all of our cities across the US, are they prepared to take under, such a grand operation?
Yeah, I mean, I think that remains one of the challenges. The utility industry, writ large, aging workforce. But I think particularly, and I'm not an expert necessarily on the workforce in geothermal, Geo-exchange. I think that it's important that we communicate with the next generation, the emerging professionals, the opportunities in our sector, and that they can not only make a living in this sector but make a difference. One of the things IDA is doing, we're holding our campus energy conference. It's here in Boston. Boston, as you probably appreciate, is a university rich area. We're holding a free session for students the Monday that precedes our main conference, so that they can attend, visit with our 140 exhibitors, the organizations that make products, have services, are active in our space. They can meet with organizations that are looking to employ this next generation and understand, well, what are the skill sets? What do I need to kind of join this kind of clean tech segment of the economy, and then they'll have an opportunity to do meetups, etc. So we as an association, we really are interested in creating more pipeline for people to understand how we have a jobs board at IDEA. There's some great jobs, at colleges and universities, not only operating, but, managing, engineering, designing, implementing. And universities are, I guess, if I wasn't doing what I would love to be working at a university, and have all the opportunities that being in that space, sports, culture, theater, arts. So, yeah, I think back to your main question, I think that remains a challenge. But I'm really, we recently had a leadership offer for young women in our sector. It's named after one of our former chairs who, God bless Patty Wilson. She died earlier this year, and so it's a scholarship or leadership program in her honor. We've had a number of women apply, and just reading, their interest, their passion, their curiosity, their commitment, their mission focused interest. It gives me confidence that the next generation really is going to carry on and probably do better faster than we have. But we got to make way. We have to. We and I think the skill sets vary. One of the areas opportunity for our space are the maritime academies, right?
Interesting.
Where students learn, how to operate, maintain resilient ship-going generating stations that where if it's not if it's not safe and efficient, then lives are at risk. And that's the case at some of our research universities. The resilience factor to maintain, these systems. So the skill sets have changed over time, right? A lot of, I think, computer skills, analysis, controls, et cetera. That's a very valuable component. But fundamentally, mechanical engineering, I think, electrical engineering, those are good precursors to the clean energy space writ large.
Okay, so I want to conclude with one final question. So IDEA emphasizes helping people learn from each other in real time. So what tools or platforms are most effective in fostering collaboration and knowledge sharing among your members?
So we hold conferences, our Campus Energy Conference, our annual conference. This will be our 116th annual conference. So that's where physically people converge. The providers, the technology providers, innovators, integrators, are all there. It's a kind of a common marketplace. And then we'll have, 150 presentations, right? So, that content is curated and delivered, and we think it's highly relevant. Our campus conference will attract 1,400 people. Many are actively involved in the university setting. Our annual conference is really geared more towards cities. It's quite global. Our members from the Middle East who have developed and are developing massive district cooling systems to support the economies of Dubai and Abu Dhabi and Doha, they're there. So that physical exchange, I think our members realized during COVID it's only the second time in the 115 years of IDA that we didn't have an annual conference. The first was 1918, the Spanish flu. The second was 2020 during COVID. Every other year we've had an annual conference. And so I think our value proposition increased because people realized what they were missing, right? The convergence, the community, the kind of the personal connectivity.
Yes.
Other times, we do a newsletter that I think aggregates and harnesses and filters, relevant content. We distribute that to, I think, 15,000 people globally every week. That's free. We do a quarterly magazine. So I think we tend to bring the lens to our sector very effectively. We're standing up a learning management system that'll harvest the content from all of our proceedings, over dozens of years. That will enable our professional engineers to get recertified, to actually get the kind of the CEUs, the classroom commitment at their desktop. And we think that'll provide a lot of value. I mean, I do think that, Elizabeth, you're in the energy space. You know how active and, kind of vibrant and evolution, just the range of we don't limit ourselves, to district energy, but
right.
But we embrace, geothermal, and we embrace we just had a webinar this week on nuclear small modular reactors, and
interesting.
And there's a really significant interest in that. Helsinki is installing 5 modular reactors to provide carbon-free heat to Helsinki, which and and so that investment. So we're looking over the tips of our skis too. We really are looking at the integration of new technologies. I think we're trying to be more proactive too in terms of education and advocacy, right? So, like geothermal, district energy tends to be underground, sort of underappreciated. We need to raise the visibility and the awareness. So, yeah, I think IDEA, our membership is growing. It's getting more diverse, both in terms of gender and technology and age. Where our demographics are getting younger, which is encouraging. I used to be one of the young guys in the space. Not so much anymore. But no, I would encourage people to visit our website, districtenergy.org. And if you're a student in New England and you're interested in coming, again, that's free. Visit our website, sign up, come to the student session. You may need to couch surf because our hotel rooms are getting oversold. But we'd love to welcome, young people. I was a young one once. We really want to help, people make a living and make a difference.
I love it. I love it. Well, I want to thank you so much
You're
for
welcome.
joining me today. And I want to thank all of our listeners for joining us on this episode of Geothermal Unleashed. I hope today's discussion has sparked new insights and deepened your understanding of the geothermal industry's incredible potential. Until next time, keep pushing the boundaries of what's possible, and let's continue working together to unleash the full potential of geothermal. Thank you.
Thank you, Elizabeth.